if you are trying to answer this with any other strategy besides a nice, simple arithmetize, I think you are risking easy points, right? So what is arithmetize again? That is when we make up our own numbers. Notice that all of these answer choices are involving the formulas for radius and volume, but they're doing it in a way that we don't actually have the radius or the volume. But they're describing this story in a way where it would be really helpful to have it, right? A manufacturer determined that right cylindrical containers with a height that is 4 inches longer than the radius. Okay, it would be really great if I could literally have a height that is 4 inches longer than the radius instead of keeping it as this R. So we're going to do that. They offer the optimal number of containers to be displayed on a shelf, blah, 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 which is the following expresses the volume in cubic inches of such containers. Okay, well, we do need to know one thing from the reference chart, so let's add that in, right? We have the reference chart in every part of the math section of the Blue Book, and a cylinder, right, is this thing right here. And so we have a formula of volume equals pi r squared h. So let's write that down. Volume equals pi r squared h. Well, what should we do with the radius? Should we make it 1? Let's see. Why not, right? Let's see how that goes, right? So if the radius is 1, then a height that is 4 inches longer than the radius, so then my height is going to be 5, right? 1 plus 4, easy to do. So that means my volume is going to be pi times 1 squared times 5, so that's 5 pi. Let's see if anything gives us 5 pi. This is going to give us a volume of 4 pi times 1, so that's 4 pi, right? Because 1 cubed is 1, and then there's no 5 in there, so no way. This is going to be pi times 2 cubed, so that's 8 pi. Nope. This is going to be pi times 1 squared, so that's just pi, plus 4 pi. So that's 5 pi, that could work. And then this is also going to be pi plus 4 pi. So I did that on purpose because I wanted to show you that this is not really a big deal, right? I picked 1 kind of knowing it wasn't going to work because I was seeing those exponents being the only difference in C and D. And that's the benefit of the number 1. We choose it, is it makes exponents disappear. But we could also just pick a new number and deal with it from there. So, right, why don't we do the radius is 2, and now the height is going to be 6, right? It's still 4 greater. Now we don't need to check A and B. We already know those choices are terrible. So we're going to continue with choice C. But first, I guess we got to get the new volume, right? So the volume is pi times the radius squared times the height. So that is 4 times 6, which is 24 pi. So hopefully C and D give us different things now. Let's try C. So that's going to be, again, I'm just plugging in now, radius is 2, so pi times 2 squared plus 4 pi times 2. So that is going to be 4 pi plus 8 pi. Not quite, that's 12 pi, so that doesn't work, but let's try D. That's going to be, this is 8 pi, because it's 2 cubed, so that's 8 pi plus 4 times 4, so that's 16 pi, that's 24 pi, and now I can confidently pick D, which is the answer. So yeah, some of you are going to do this without that, but I just feel like it's risky, and you know, it's just going to be weird. You might do something wrong. For me, even when the strategy failed at first, it wasn't a big deal. I was able to just say like, okay, well now I at least know what I need to do. I'll change the numbers and move from there. And some of you with practice with arithmetize, if you force yourself to use it, are going to be smart enough to know that the number 1 would not have been a good choice here, and maybe choosing the number 2 is better. But let me know your thoughts. I know a lot of you are going to comment, oh, it's actually really easy to do the algebra, but I don't know. I've seen a lot of people say the same thing and then get stuff wrong. And if you're showing up with SAT scores at 700, I think that being able to quickly spot arithmetize kind of situations is how you get them to 780, 770. You need to be flexible. You need to know the errors are coming, and that arithmetize is a big way to prevent them.